So this lesson is going to be rewriting expressions with radicals. And the first one we have is the square root of 81d to the 6th. Now remember, underneath here is what we call the radicand. Now, we prime factor this 81 first. So 81 is 9 times 9, and 9 is 3 times 3, and 3 times 3. So, and then we'll do the d's. So if we write this out, this would be 3 times 3 times 3 times 3 times d, 6 d's. 1, 2, 3, 4, 5, 6. Okay. Now remember, this is how, whenever we have a pair of numbers, 3 times 3 is 3 squared. To take the square root of 3 squared, it's just 3. So every pair of numbers that we have underneath, we're going to pull one out. So this would be 3 times 3, and then we have 1, 2, 3 d's, times d, times d, times d. And if we were to simplify that, that would be 3 times 3 is 9, d times d times d is d to the third. So d to the third would be our correct answer right there. Another way you can look at this is if I get down here to right here and I notice that I already have a pair, I don't need to completely factor those down because I could rewrite this as 9 times 9 times d, all those d's. And then the same thing is going to apply. If I have a pair of 9s, one comes out, and then I have 1, 2, 3 d's, so 9d to the third. We're going to get the same answer. Okay, let's look at this one. Simplify the radical of the square root of 18a to the 9th. So let's start with 18. So we have 18. We know that is 2 times 9. Those aren't a pair, so we got to go some more. And that's 3 times 3. So if I were to write this out, I would have 2 times 3 times 3 times, and then I have 9 a's. 1, 2, 3, 4, 5, 6, 7, 8, 9 a's. That's a lot of a's. Okay, so now to simplify this, we're just going to look for pairs. So 2 does not have a pair. It's going to stay underneath the radical. We have 3, and then I'm going to circle every pair of a's. There's 1, 2, 3, 4 pairs of a's, and 1 is left underneath. So I'm going to bring out 1, 3. Whoops. I'm going to bring out 1, 3. And then 1, 2, 3, 4 a's. A. And underneath the radical, we still have a 2 and an a. And then we can simplify this. 3a to the 4th times the square root of 2a. So that one would be this one right down here. Now when we're combining radicals, this is adding and subtracting. It's a little bit different. So these are similar to like terms. If we have 2x plus 3x, we have the same terms, the same like terms, so that would be 5x. It's kind of the same thing when we're looking at this by using the distributive property, just like we would do with here. So if we pull out an x of this, that'd be x times 2 plus 3, x times 5, which is 5x, the same thing. We're going to do the same thing with this type of problem. So if we have the square root of x is common in both of these, so that's the same thing of saying 9 minus 3. And then we know 9 minus 3 is 6, and so we could rewrite this as 6 times the square root of 6. It's so similar. Once we know that these are the same thing, then it would be 9 square root of 6 minus 3 square root of 6 is just 6 times the square root of 6. We just do the 9 minus 3 because these are the same radical, this and this. So let's look at one where they're not the same. So we have 4 times the square root of 7 plus 3 times the square root of 28. Now these radicals are not the same. So let's simplify this 28 and see if we can get anything the same. So we have 4, square root of 7 plus 3, and then 28 is going to factor into 4 times 7. And 4 times 7 equals 2 times 2. So this will be simplified into 2 times 2 times 7. Now we look at this, we say, hey, we can simplify this radical right here because I have a pair of 2's. So if I already have a 3 outside, I have to 3 times the 2 that comes out and leave 7 underneath. So now I have, oh gracious, 4 radical 7 plus 3 times 2. So this is 4 plus 6. Now when we're doing this, the 7 is the same. So we're going to separate out, distribute that 4 plus 6. And so 4 plus 6 is 10, and then we still have our radical 7. So it would be this. We do not add, like this one right here, we don't add what's underneath the radical. That's the term that is like. So the square root of 7 stays the same, and we add the 4 and the 6. When we're finding the product of radical numbers, we can rewrite this as, I'm going to factor this. This is 2 times 3. This is 2 times 6, which is 2 times 3. So there's a couple ways I can do this. I can factor them each like that, and I can say, well, that's all equal to the square root of 2 times 3 times 2 times 2 times 3. So I take all of my factors, and I can write them all underneath 1. And then, like we always do, we take out pairs. So I have a pair of 2's, and even though they're not by each other, I still have 2 3's. So I pull out one of the 2's times one of the 3's, and I'm left with the 2 underneath. So that would be 6 radical 2. Another way of looking at this is I could say, well, I already know this is 6, and I know 12 is 6 times 2. So I could do 6 times 6 times 2, have a pair, so that would be 6 radical 2. I'm going to get the same answer. So when you can identify pairs underneath the radical, that's how we always pull one out. So you can prime factor them all the way down, or you can do it that way. Find the product of the square root of 4 times the square root of 8 plus 3. So in this one, let's look at the distributive property. We're going to use the distributive property, but let's simplify this as much as we can first. So the square root of 4 is equal to 2. The square root of 8 is equal to the square root of 2 times 2 times 2. So that is equal to 2 times the square root of 2. And then 3 is just 3. So if I were to rewrite this, I would have 2 times the square root of 2 plus 3. Now we're going to use our distributive property. 2 times the square root of 2 is 4 times the square root of 2, and 2 times 3 is 6. Now because this one has a radical and this one does not, we can't combine those terms, so that is as simple as it goes. So this one right down here. I think that's all my questions. So if you have any other help, need any other help, or further examples, please reach out to me through email or text, and I will be able to help you.